Good morning. We are the Virginia Tech MSBA BA team working with Ed McLarney on evaluating artificial intelligence to improve research processes within NASA. First, I'd like to begin with some team introductions. Hi, my name is Ellie Rule, and I received my bachelor's degree from Virginia Tech in finance with a concentration in corporate financial management.
Hello, everyone. My name is Emily Lyric, and I received my bachelor's degree from Virginia Tech in hospitality and tourism management.
Hi, my name is Zacchaeus Locavere, and I graduated from Virginia Tech with a bachelor's in business IT and a concentration in decision support systems.
Hello, everyone. My name is Brandon So, and I received my bachelor's degree in marketing from Virginia Tech.
We'd also like to take this time to introduce and express our gratitude to both our sponsor, Ed McLarney, as well as our faculty advisor, Dr. Ona Thurek, for their continued guidance throughout the entirety of the project. Now I'll get into a brief overview. So our project came to fruition as NASA, being at the forefront of scientific exploration and discovery, conducts a large amount of research in a variety of areas. The manual nature of these research processes is often costly and time-consuming, as researchers are forced to use a variety of tools to accurately complete their work. NASA is addressing this challenge by moving towards digital transformation in order to automate and streamline these processes. This allowed us to pose the key question of how can NASA best implement various AI capabilities to save both time and money and perform better processes. Our team created a framework based off identifying several key primary factors that we saw to influence the project outcome. The first thing we looked at is how to better automate the analysis of this big data. This led to the broader scope of enhanced digital transformation efforts within NASA to improve operations and decision-making processes. This enhanced transformation can be sparked, as many of you know, in recent years, AI has made significant leaps and bounds, offering new and powerful tools. We look to leverage the current tools available, as well as explore the emerging. And finally, the ultimate goal of our project was research optimization within NASA. This was done by improving productivity to maximize each research dollar spent. Understanding both how the project developed as well as the underlying factors allowed us to create the simplified problem statement of how can NASA integrate AI capabilities to better perform research for the organization. Our team set several objectives in order to address this goal. These were to research existing and emerging AI capabilities, gather insights from professionals and industry standards, understand the underlying factors of research processes within NASA, compare and contrast different technologies, tools, and strategies available, and finally, create a comprehensive framework for technology optimization. By systematically doing all this, we are able to ensure the successful implementation and optimization of AI capabilities for research purposes within NASA. Now I'd like to pass it off to Emily to go a little more in depth about our research and analysis.
Thank you, Ellie. So as we began our research into different AI technologies that we knew to be on the market that we believe can be best suited in helping NASA optimize their research, we wanted to consider four main elements. The first being the actual capabilities that each of these AI research assistant technologies has to offer in helping a researcher throughout their entire process. We also wanted to look at whether or not the tools we were investigating would bring some sort of return on investment to NASA, as well as be able to handle an enterprise integration on a larger scale within their organization. And since NASA is a large government agency with different security and ethics policies in place, this came at the forefront of our mind to consider as well when looking at these different AI technologies. As we began our research and really got into it, we started with an initial market research that we conducted as a team. Following this, we looked at some of the tools and technologies on the market that we had investigated and did live demonstrations with companies we believed to be viable options in really helping NASA with their research optimization processes. We then concluded our research by conducting interviews with a variety of researchers from different backgrounds to help us understand which tools are currently helping them the most within their research. From our research, many of the capabilities that we're looking for in an AI research assistant we found are currently on the market right now. Some of these include literature review, personalized suggestions and content generation, generative AI, which includes tools that you might be familiar with like ChatGPT, citation management, and credibility assessments to make sure that the information we're gathering from these tools is reliable. Overall, the research process was very beneficial for our project as a whole in understanding the problem space and identifying key solutions for NASA. We found that we gathered a lot of qualitative data using a template that we used throughout this process to help us answer questions about the companies we were looking into and identify their objectives and see how they align with ours. From this, we knew that we wanted to find a way to quantify this abundance of qualitative data we had, and we found that through the creation of an analysis framework to allow researchers at NASA to be able to rate and rank different AI tools on the market as they emerge, concluding our project, would be the best step moving forward in research optimization. The analysis framework that we created as a team is an official scoring matrix, which Zaki will now introduce to you all.
Thank you, Emily. So as we mentioned, due to the ever-growing nature of AI, we thought it was critical for NASA to have a systematic method for evaluating AI research technologies as they continue to emerge. So this idea led to the creation of our scoring matrix. So this matrix is broken down into 4 main categories, and they are key capabilities, implementation, return on investment, and privacy and security. So within each of these main categories, there are subcategories. And within each subcategory, there are actual criteria. So these criteria are direct benchmarks for AI technologies that we create as a team, and we derive these from the insights we gained throughout our research. So these criteria with the user will go in and evaluate using a Likert scale from 1 to 10, with 1 being the criteria is not satisfied at all, and 10 being the criteria is perfectly satisfied. So once the user ranks each of these criteria, a score is calculated for each of the subcategories. The user will then assign a weight to each of the subcategories, and a score is calculated for each of the 4 main categories. Finally, the user will assign weights to each of the 4 main categories, and the end result is a total score for the technology as a whole. So to see what this actually looks like in Excel, we provided some screenshots. So the first page you'll see when opening the workbook is the results page, and this shows each AI technology's total scores along with their respective rankings. And each of the 4 main categories also has a separate sheet in our workbook. The next one, we'll take a look at one of these main category sheets. So this is where the user will go in and enter their rankings for each of the criterias, along with the weights for both the subcategories and main categories. All 4 of the main category sheets are formatted identically with a summary table at the top and then a separate table for each of these subcategories. So the main goal of the scoring matrix is to quantify the evaluation process for AI research technologies. But while this is the main goal, we believe that the key to our matrix is that it is heavily customizable to the needs of different analyses. So the content is customizable from criteria and subcategories to the main categories. So as we all know, the field of AI is changing very rapidly. So as new potential capabilities emerge on the market, they can easily be added into our framework. Additionally, the weights for both the subcategories and main categories are completely customizable. So for example, if at one point in time, NASA is more interested in the implementation of a certain technology and thus on the capabilities, the weights will be adjusted accordingly, and that will reflect in the final score. Overall, the matrix provides NASA with a means of evaluating all aspects of AI research technology based on the current needs of the organization. And as these needs change, our framework adjusts alongside. The result of the use of our scoring matrix is ultimately a better informed decision when it comes to choosing which technologies to invest in. Now I'll pass it off to Brandon to talk about the economic impact of our project.
Thank you, Zaki. So our estimates are in terms of productivity savings and are broken down into good, better, and best case scenarios based on different levels of employee adoption. The good case has a 50% chance of occurrence, while the better case and best case scenarios have a 30% and 20% chance of occurrence, respectively. Using these probabilities, we then calculated the expected value for years 1 through 3, which is about $10.6 million for year 1, $21.3 million for year 2, and $42.5 million for year 3. So in conclusion, our team's overall goal was to help move the needle in favor of NASA's AI research assistant endeavors through project development, research, analysis, and the creation of the scoring matrix. We wanted to help initiate a crowdsource challenge at NASA to harness diverse ideas and skills that may not be present in-house. Crowdsourcing is a unique approach to innovation that allows NASA to fully leverage the scoring matrix. And now we would like to share some quick comments about the MSBA BA program. The most impactful content to us was the capstone project because we gained real world experience that will surely benefit our future careers. The program fosters a very collaborative experience, and this emphasis, collaborative experience between the students at the faculty and the sponsors. And this emphasis on collaboration over competition is really fundamental to the program. And a good piece of advice that the last cohort left us with, and that we would like to pass on to the next cohort, is that you get out of this program what you put into it. So we encourage the next cohort to pursue its ambitions with hard work and commitment. And finally, we want to express our gratitude to the NASA team, as well as to the Virginia Tech CBA team for their support and guidance over the past year. Thank you all for listening to our presentation. We will now open up to questions.
There are four different categories for me. Were they all 25, 25, 25, or were they making money but not?
Yeah, thank you for your question. So the question was, what were the weights for each of the main categories?
Yes.
So those are all user driven. So the user will go in and enter those weights for the specific analysis that they want to do at the time.
So there isn't like a corporate standard that says.
Yeah, and so we thought about assigning weights ourselves, but with discussion with our sponsor, we believe that it was best for the researchers that are actually going to be using the technologies that they're evaluating for them to be the ones to assign the weights.
Thank you.
Yeah, so that's all covered in the implementation section of our scoring matrix. So based on what the researcher wants at that time, whether they want a cloud-based service or a different type of service, they can rate that higher or lower onto the scale, and that would reflect the score of the matrix.